Hi dear folks, today's Leetcode question is to sum problem. In this input array is sorted. Let's get quickly started. What's the input given and what is the output required? Here are the input statements. First, it's a one-dimensional array of integers like 2, 7, 11 and 15. Second, the numbers are sorted in ascending order. Third, the test cases are in such a way that there is just one solution possible. Fourth, the solution can't use the same element twice. Like 7, we can't sum it twice to form 14. Fifth, the solution must use only constant extra space. That means we can't use any data structures like hash map for a solution. And what's the output? What's the output required from this problem? We have to find out two numbers such that they add up to a specific target number. For example, the target number given is 9, and from our input array we are having two elements which forms this target number, that is 2 and 7. So output would be in the form of an integer array which will represent indexes of these two numbers. So what's the index of 2? It's 0. And what's the index of 7? It's 1. We are just adding 1 in that index number. So it's 1 and 2 would be the output. We solve this problem using three approaches. First is brute force approach. Here we can start iterating the array and we can find out the another elements equals to target sum minus current element in the remaining array. So here the current element we can take it as 2 and we can find the another element equals to target sum minus current element, which is 9 minus 2 is equals to 7 in the remaining array. And once we find the appropriate result, we can store it in output array and can return it. So the time complexity of this approach is O(n square), which is not such a good one. Let's move to the second solution. Here second approach is two pointer approach. Here we can use two pointers. One is left and second is right. Left will point to the leftmost index and right will point to the rightmost index. And we can check if the array element at left plus the array element at right index sums up to give the target sum. We got our answer. And if the sum of the element present at left plus right is lesser than our target, then we'll shift our left pointer to the right, and otherwise we'll shift our right pointer to the left. Let's see with the help of an example. The last approach here is binary search. Here we'll use three pointers: left pointer, right pointer and mid pointer. Here firstly we'll calculate the current sum using the element present at left pointer and right pointer, and then we'll check if our current sum is equals to target sum, then we got our answer. Otherwise we need to shift our window either towards the left or right from the midpoint depending on the current sum. So here the current sum will be sum of array element present at left index plus the sum of array element at right index. So first condition would be, we'll check if current sum is equals to target sum, then we got our answer. Second condition is, we'll check if current sum is lesser than target sum, then we know that we need to shift our left pointer towards the right. But by how much value? That depends on one condition. We'll check if array element at mid index plus array element at right index its sum value is lesser than target sum, then we'll make our left pointer is equals to mid plus 1, else we'll just increment our left pointer by 1 value. Last condition is we'll check if current sum is greater than target sum. Then we know that we need to shift our right pointer towards the left. That again depends on the condition if array element at mid index plus array element at left index, that's their sum is greater than target sum, then we'll make right pointer is equals to mid minus 1, else we'll decrement right pointer by just 1 value. Time complexity of this approach is O log n, which is the best among all the three approaches. I have written code in all the three approaches: binary search, two pointers, and brute force. It's just in place of left I have used I, and in place of right I have used j. And this is also accepted, and the best time complexity of 100% is being achieved using binary search approach. That's it for this problem. Thank you for watching this video.